book takes on one dominant idea that is shared among many mainstream scientists in biology, medicine, and especially psychology. This idea is formally called the brain organization hypothesis or brain organization theory, but it is not usually named as either a hypothesis or a theory. It is instead taken as a simple fact. The idea is that there are male and female brains, and that these male and female brains exist because of the hormones that we are exposed to early in development. Because of hormones, the core features of, quote, thinking like a woman, or feeling like a man, or being heterosexual are firmly hardwired before we are even born. Individual experiences and social structures might tinker with male and female natures around the edges a little bit, but the typical or normal situation is that there is a predictable kind of human nature that goes with a male body and a quite different sort of nature that goes with a female body. Some people doing this work hold extreme versions of this view, and others think that hormones have much more subtle effects on just parts of the brain or very particular behaviors. But they all agree that some of the stereotypical average differences between women's and men's desires and behaviors are set up by early hormones. Brain organization theory is especially focused on androgens, the so-called male sex hormones. According to the theory, high androgens during very early development, meaning the fetal or neonatal stage, create a masculine pattern of interests, mental skills, behavior, and sexuality. If androgens are low or absent during the critical period, a masculine pattern for these characteristics develops: interests, mental skills, behaviors, sexuality. If androgens are low or absent during the critical period, it's a feminine pattern instead. Already, some of you may be itching for more detail. After all, androgens is a very general term for hormones that include testosterone, androstenedione, dihydrotestosterone, and others. You might have the sense that they don't all do the same things, and you would be right. I would like to be more specific and tell you which particular hormones are involved in the studies I examined, but I can't, and this is in fact part of the problem. Most brain organization research in humans doesn't involve actually measuring any hormones. Instead, the research mostly involves people who have particular clinical conditions, like congenital adrenal hyperplasia, or CAH, which disrupts many hormones during development, including elevating several androgens. A common design is that girls or women with this condition are compared to their female relatives who do not have CAH, congenital adrenal hyperplasia, to see if the two groups have different behaviors, skills, or interests. Any differences found are chalked up to the early androgen exposures. Or worse, they are chalked up specifically to testosterone, which is affected considerably less than our other steroids in this condition. Now, there are enormous problems with this conclusion, including the fact that there are many other metabolic and physical effects of the condition that are totally ignored. And a large proportion of girls with this condition go through intensive medical management that frequently includes multiple genital surgeries. There are so many differences between the physiology, physique, and experiences of girls and women with CAH that chalking any differences up to prenatal androgen exposures is a real stretch. This could be my whole talk tonight, but it's actually all I'm going to say about that particular problem. Another common design is to begin at the other end of the causal chain. So the idea is hormones during early development affect the brain. This affects particular behaviors or personality. Some studies start over here with people that we have some idea about the kinds of hormone exposures, nothing too particular. Other studies begin over here, looking with the behaviors and traits that are supposedly shaped by the hormone exposures. So many such studies compare gay men to heterosexual men, or lesbians to heterosexual women, although fewer. And they look for evidence that another trait, supposedly affected by early steroid exposures, is also different between gay and heterosexual men. These other traits include things like being left-handed versus right-handed, or having a particular pattern of finger lengths, the 2D, 4D studies, or having a different feature in some brain structure. Again, these are studies that look for traces of hormone environments from decades earlier. No actual hormones are measured. Now, I critique this theory very strongly, but again, most scientists do accept it, even though their own work may be very far from this field, because sexual organization of the brain by hormones is taught as classic principle of development. Now, let me be clear about what I do not question. Steroids are important. They play critical roles in the development of literally all organs, including the brain. And androgens are key for male genital development in humans as well as other animals. Animal experiments also show steroid hormones to affect a lot of behaviors. But there are important variations across species in how hormones affect sex-type behavior, and equally large differences in which behaviors are even sex-typed in the first place. I'm particularly interested in how this theory has been applied to humans, where there are very few reliable sex differences in behavior, in contrast to stereotypes, and I'll return to this point later. You might think that you've never heard of brain organization theory, but it dominates public understanding of the science of sex, gender, and sexuality. These are just a few clips of fairly recent reports to let you know. And whenever you hear of a study that makes claims about why behaviors are different between girls or boys, or why men and women choose different career paths, sometimes the claim will be about why more boys have autism than girls, or why some people choose same-sex versus other-sex partners. Chances are that you're hearing, Chances are that you're hearing about a study based on this brain organization theory. Likewise, when you read of studies that claim to explain why some people reject the gender that they are assigned and instead wish to change their gender and often their bodies, you are almost always hearing about research based on this one very influential theory. So this theory is too important to ignore. The rest of my talk has three parts. First, I'll talk about my own methods a little bit. Next, I'm going to talk about some of my evidence and we'll show you why brain organization is a very bad explanation for human gender and sexuality. There are many other reasons besides the ones I'll tell you, but I've just chosen a few, so you have to buy the book. So this is very good marketing. Finally, I'm going to talk a bit about some recent evidence that's emerged since my book was published that suggests brain organization theory might be trying to explain a phenomenon that doesn't even exist in humans. Okay, so for this book, I analyzed, there it is, that's what I said I would look at. This book, I analyzed literally all of the studies that claim to provide evidence about brain organization in humans over a 40-year period. I did look at a lot of animal studies, but my direct analysis is based on the human research. I also interviewed about 20 of the most influential scientists in the field. My goal was to understand how the studies fit together as an entire network. One really important thing to understand about brain organization theory is that you cannot do experiments to test this theory in humans. That would require complex surgery on human fetuses, removing their own ovaries or testes, and then randomly assigning the hormones they're exposed to before birth. This is impossible both ethically and even logistically, actually, even if you were evil enough to try it. So instead of experiments, the theory must be judged by analogies to non-human animals and by this network of uncontrolled, partial studies in humans. This is not news. People doing brain organization research have acknowledged this fact for decades, but they have very different opinions about how much it matters that the human studies aren't experiments. And that the studies are mostly very small and very statistically weak. I found many other methodological problems that, again, I don't have time to go into. Many people argue that because there are so very many studies that support this theory, it doesn't matter much that the evidence from any single study is weak. I will show you the problems with that argument. In epidemiology, studies like this, in which scientists cannot control the variables, are called observational studies or quasi-experiments. Now, that's not an insult. That's just a way of saying that the scientist does not have the ability to control the variables. My doctoral training focused very heavily on epidemiology and biostatistics, and that's a field where quasi-experiments are the norm, not the exception. Think about studying toxic chemicals or viruses. As soon as you even suspect that something causes disease, you can't ethically assign some people to get exposed to that chemical or virus, and others not to be exposed and see what happens. Usually, you can only observe what happens to people who are and aren't exposed and go from there. But epidemiologists recognize that there are pitfalls with this kind of research, because you can never be sure whether something you did not measure, perhaps something you have never even thought of, is actually responsible for the differences between groups you compare. So epidemiologists have some standard ways of dealing with this. For one thing, I'm going to go back one. Let's see if I can. Nope, that's not that. How do I go back with this? There we go. Nope, I want to go back. There we go. For one thing, you have to pay very close attention to definitions and measures. And now I've lost where I was here. Let's see. Just a moment. So you don't want to compare apples and oranges. Maybe the simplest way to explain how I analyzed brain organization research is this example. When scientists conducting brain organization studies asked, do androgen exposures cause masculine sexuality? I asked, what is masculine sexuality? And when they asked, do homosexuals have low androgens early in development? I asked, who counts as a homosexual? Now, these questions were sometimes irritating to the scientists I interviewed because they seemed to be esoteric questions or possibly even rhetorical. But in fact, I was interested in very practical, concrete matters of how scientists defined and measured the things they were studying. Another thing epidemiologists know about quasi-experiments is that you must use a variety of study designs so that you don't just repeat the same strengths and weaknesses over and over again. But even if you do both those things, you still have to be humble and recognize that claims built on quasi-experiments will always be on shaky ground. A classic example of how quasi-experiments can be misleading is the case of so-called hormone replacement therapy after menopause. For more than 60 years, in the 20th and early 21st century, doctors prescribed estrogen and/or progestin to millions of women to manage symptoms of menopause and to prevent some diseases that increase with aging, especially heart disease and osteoporosis. This practice was supported by scores of studies, including one meta-analysis that grouped data from 51 separate studies and included more than 160,000 women in total. That's a lot of data. That's way more data than we have all combined for brain organization research. Now, those studies showed that women taking estrogen alone had 30% to fewer coronary events, such as heart attacks. So it seemed to many doctors like a good idea to prescribe hormones after menopause, especially for women at higher risk of heart disease. But estrogen, as well as estrogen with progestin, increased the risk for some cancers, so there were questions about risk versus benefit. And there was also the problem of the healthy volunteer effect. That is, women who were already healthier and getting good medical care were the ones most likely to be taking hormones after menopause. So you can't simply compare women taking hormones to those not taking hormones and chalk all the differences up to the hormones, usually the estrogen. These questions prompted the development of a massive placebo-controlled, double-blinded study, a true experiment called the Women's Health Initiative. And this study turned medical understanding of hormone replacement therapy on its head. When given to healthy postmenopausal women, estrogen alone did not protect against heart disease. In fact, it actually increased the risk of stroke, and estrogen combined with progestin increased not only stroke, but heart disease and serious blood clots. So it was at best neutral on the thing it was supposed to prevent, but it caused many other problems. And the full results of these huge clinical trials are more complex than I have time to review here. There are many, many different nuanced findings on different diseases, but I'm just making the point that what the observational studies showed, even though they were very large, very good studies, done by excellent scientists on massive numbers of people, far more than have ever been in brain organization research, these studies showed something very different from what the controlled experiments showed. So there's no substitute for experimentation. But sometimes, as when you are trying to understand hormone exposures that happen very early in human development, even before birth, experiments are out of the question. In that case, you have to be very, very careful, and you should be very, very humble. You have to pay special attention to measures and study designs, and you should not overreach with your conclusions. So I decided to look more closely at the measures and study designs than had been done, and I found some surprising things. All right, that's what these were the results from the WHI. Sorry, I didn't come to that slide before. Okay, so that's the big difference. Okay, so brain organization studies claim to have linked early hormone exposures to a wide variety of traits, especially masculine and feminine patterns of sexuality, sexual orientation, childhood play behaviors, aggression, career interests, and cognitive skills like spatial relations. Surprisingly, the majority of studies I examined offered only vague definitions or no definition at all for these outcome variables. Meaning the trait or behavior that's supposedly influenced by the early hormones. In my interviews, scientists often told me that these traits were, quote, common sense, so it was not necessary to focus a lot of effort on developing good measures. For example, several scientists told me that feminine sexuality does not require sophisticated measurement because the concept is obvious and, quote, a no-brainer. Yet what was considered normal feminine sexuality when the earliest studies were done during the late 1960s is so profoundly passive and reserved that today it would meet sexologists' definition of sexual dysfunction. Let's take a look at that. Okay, notice that in this diagram, masculine sexuality, which is over here, is signaled by a very active and dominant approach, having active desire rather than simply, quote, responding to a partner's desire. Having desire for its own sake, desire outside of a love relationship or a monogamous relationship, having multiple partners, masturbating, among other things. Women reporting these kinds of desires and behaviors were viewed as masculinized. If a woman reported any one of the things over here, for example, being aroused by visual stimulation, or masturbating, or saying that she enjoyed more than one sexual position. This is a really interesting one, because that was taken, you would get a point for masculinization in the early studies if this was something that you reported. Now, one thing you should just know quickly is the women who were being studied were overwhelmingly women with congenital adrenal hyperplasia, and most of them had not been treated until adulthood. Even if they had, whether or not women have been treated early, there are, in general, genital differences between women with congenital adrenal hyperplasia and without. And one of the differences is typically a small and inflexible vagina. So enjoying different sexual positions besides classic penetration seems like a very smart way for women to figure out how to find sexual pleasure in their relationships. But in these studies, it was taken as a sign that they had been masculinized in their brains, right? Okay, now what happened in the early 1980s? As you can see, by the early 1980s, the whole pattern changed. From about 1981 to 84, there are several studies that do both patterns, and then from 84 on, every single study follows this pattern only. Some of the features that were previously taken as a signal that a woman was masculinized were now taken as an essential component of female sexuality. Women who reported less genital arousal, fewer partners, less active libido, less masturbation, were now seen as less rather than more feminine. But all of these studies are strung together as if they're all testing the same phenomenon of feminine sexuality, and they're all lumped together without noticing that what goes on underneath that term, feminine sexuality, makes an absolute 180-degree switch. So the later studies use definitions that absolutely aren't compatible, but researchers do not acknowledge the shift. They string together the studies as if they're mutually supportive. So just as some researchers told me that feminine sexuality is a, quote, no-brainer, other researchers told me that sexual orientation is a very simple and obvious concept. Here is an excerpt from one of my interviews with a prominent psychologist whose work on brain organization is cited very often. I apologize for the long text, but I love this quote. I asked him how they had determined that sexual orientation, in order to group men in a particular study, how had they determined who was a gay man? And he told me this. Note, I call them Dr. A and Dr. N because I promised them privacy when I did the interviews. So this doctor, Dr. A, said, Fritz Klein, another psychologist, had some complicated grid for determining sexual orientation, and Dr. N, this is the other guy on the study, who was doing the bulk of these interviews, said, you know, these are all nice scholarly heuristics, but 99 times out of 100, listen to the subject, and they'll tell you who they are. You don't run into too many straight men who lie and say they're gay. You may have some gay men who will tell you they're heterosexual, but not if they know that the confidentiality of the project is high. So I'll pause here and say, throughout the interview, it became clear that when he said, first they tell you they're gay, then they tell you they're straight, what he was talking about was that people would say they were gay, but then say, over the last year, one of my partners was a woman. Sometimes I desire women. Mostly, yeah, I'm straight, but a few times, a year, I might have sex with another man. And this is the kind of flip-flopping they were actually talking about. Okay, so far so good. You trust the subject, you listen to who they are. But here it begins to get messy. He says, under questioning and interactions and interchange, as well as filling out questionnaires, if they're consistent, we keep them as subjects. If they check off straight, and then they start checking off gay, and then they tell you straight, and then they tell you gay, we're not sure what's going on. We're not sure if the person is just having fun with us. We're not sure if the person is themselves not sure of who they are. And when that would happen, would exclude them from participating further in the study. Now, you might think, okay, big deal, so they got rid of a few people. But it turns out that these studies exclude quite a large portion of the people who initially volunteered. In the study we were talking about here, 40% of the men who initially volunteered were rejected because of inconsistent answers about sexual orientation. And they had specifically advertised for men who identified as homosexual or heterosexual. So it probably was already a little bit biased against men who identified as bisexual. So maybe they would have had to get rid of even more if they had recruited. Now, these researchers didn't say whether those men who dropped out were more likely to self-identify as gay, as straight, than as straight, but that difference matters. They very likely created a biased sample by adding this special criterion of perfect consistency over the lifetime. Because inconsistency is not noise in the data, it is the phenomenon. Here's some rather old data, but for the United States, it's still one of the best indicators we have about how people in the general population experience sexuality. These two simple diagrams summarize any kind of same-sex sexuality. This was a large general population survey. It's from Lauman et al. In the United States, and it's in adulthood. The figure on the left is women, and on the right it's men. And what you'll see is that some people experience only same-sex desire. Those are the people in the lightest part up here. Some people have only same-sex behavior. Nobody only identified as a lesbian, but didn't have either desire or behavior. But over here, interestingly, they had a few men who identified as gay men, even though they said they didn't really have any desire, maybe right now, and they hadn't had sex with any men. But you notice that these different areas of overlap show you how the dimensions of sexuality go together and how they don't go together. The really important thing to look at here is the center, because that's where you have perfect consistency. And notice that it's a real minority in each group, especially for women. Only 15% of women in this national sample who reported any kind of same-sex sexuality were perfectly consistent. And only 24%, only a quarter of the men in the sample were perfectly consistent. So it's interesting, again, I don't have time to do all of this, but if I were to show you the theoretical pieces that these researchers write, the fascinating thing is that most often they say desire is the number one thing. Desire is the most important element. That's the thing that's probably most affected by early hormones. But take a look at how different desire is from that group with perfect consistency in each case, right? So what that means is when they recruit people who are only totally consistent, they get a biased group. They get a group that's unusual. They're not measuring the thing they say they're measuring, okay? So when I asked scientists how they measured sexual orientation, or when I looked for measures in studies, the most common answer that I got was that they used Kinsey scales. Now, Kinsey scales are not actually questions. It's the scale that runs from 0, exclusively heterosexual, to 8, exclusively homosexual, is a framework for answers. It's not a question. It also was not meant to rate people. It was meant to rate very specific aspects of behavior and desire, such as who you find attractive or who you've had sexual contact with over some time period. Most of the studies never describe the actual questions they used to rate people according to a Kinsey scale. And if you remember the figures I just showed you, that's really quite important, because if one study was asking about behavior and another about desire and another about identity, and they just wanted one Kinsey scale, or maybe the study was quite sophisticated and it asked about all of them, and then it averaged the score for the Kinsey scale. Either way, studies using those different approaches aren't the same thing. Now, if one scientist, a Kinsey 8 in a study that asked about desire is not the same Kinsey 8 in a study that asks for perfect consistency. In interviews and in their more theoretical articles, you find this kind of disagreement among people doing brain organization research, but you can't find that disagreement in these studies. But pretend for now that they've all asked the same question, and they all come up with a score for their subjects according to 0 to 8. Let's look at another problem. That problem is just how much same-sex desire or behavior is required, to classify someone as homosexual. These are a bunch of the different kinds of questions that you could actually ask. And these are some examples of different studies, just to give you examples of the different kinds of questions people asked. But pretend there's not that variety. Pretend they all ask the same thing. Where do you draw the line? In brain organization studies, mostly scientists want to compare dichotomous categories. Almost all the studies compare one group to another group. They don't have enough people to use a continuous variable. They want groups that are dichotomous. So how do they create them? Where do you draw the line? This figure shows the different cut points that different scientists used to classify their subjects as homosexual, heterosexual, and in a very few cases, bisexual. As you can see, different studies used different points. In fact, different studies chose every single point along the line has been chosen by different studies I'm not sure why we have a 6 here. This is not. I see it with 6 categories. It's not a perfect slide, but you get the sense. Every single point has been selected, which is quite shocking to me. And in that, some say that any little hint of same-sex desire is a signal that sexuality has been affected away from typical development. And others say we only want the most pure homosexuals because that's where we're going to find the best evidence. And again, you're dealing with very, very different phenomena. Now, aggression is another supposed trait that is looked at in some of this work. And here, what's interesting is this is a good example of how scientists often drop out studies and results that don't support the theory. So there are many, many problems that include things like using far too many variables for the research, especially on very little samples, failing to correct statistics for making many, many comparisons. But one of the biggest problems is that those comparisons that seem to support the theory rise to the top, while the ones who don't support the theory sink like a stone in a pond, never to be seen again. And aggression is a great example. In 1997, the psychologists Sherry Barenbaum and Susan Resnick reported that adolescent girls and women with CAH, again, that's the condition that's been studied a lot, and it just provides a lot of good examples. They reported they were more aggressive than their female relatives, and that this was due to higher prenatal androgens. The aggression measures in the study came from a standard personality questionnaire, something called MPQ, and also this CBCL. I won't go through for you what they stand for. But on both of these measures, Barenbaum and Resnick found that the girls and women with CAH were more aggressive. Now, this study from 1977 has been cited nearly 200 times, and it's still being cited. Some of the recent citations, quite a few of the citations are in the last decade. And it's considered some of the strongest evidence that prenatal androgens increase aggression. However, in another report just a few years later, Sherry Barenbaum in 2004 was focusing on, quote, overall psychological adjustment. And here, actually, the motivation for that study was to say that in contrast to some critics who had said, it's not that CAH is masculinizing the brain, but that you're finding general disruption, you're finding overall problems. So she said, no, that's not the case. Let's look at overall psychological adjustment. And they used these big standard questionnaires, and they found that there were no differences at all in this larger group of women and girls with CAH compared to people not affected. But it turns out that that big study, where there were no differences, had the exact same subscales of aggression that that little study had. It also included the same girls in the first study, but also included many other people. So you have a small study that just focuses on aggression. A couple of the aggression measures appear to be different. You do a bigger study that's comprehensive but includes the same scales. Now, it's interesting because if you do a search in the literature for testosterone and aggression, or CAH and aggression, you can't find the second study. You can't find the negative results. Why is that? Because there were no findings about aggression. It wasn't different. So it doesn't show up anywhere in the article. It doesn't show up in the abstracts. It doesn't show up in the literature review. You have to already know that these big standardized questionnaires have the aggression subscales that were reported in the other studies. So you have to look for the studies that used this MPQ and CBCL and so on. Do you follow? So it happened with that. So it ran away. The difference just dropped out. This pattern of reporting and of citation systematically buries the evidence that doesn't support the theory, which is most of the evidence out there, while incorrectly amplifying small and idiosyncratic studies that seem to show support for the theory. Without going into more detail, I'll mention that studies on diethylstilbestrol, or DES, show this exact pattern. Diethylstilbestrol, even though it's an estrogen, it's a synthetic estrogen, and ever since some animal experiments in the early 70s, it's been theorized to be something that would masculinize the brain. I can't go into all the reasons. And in the human studies, when it was first just thought of as an estrogen, there were a number of studies that showed, oh, boys exposed to DES, this estrogen, are more feminine. Then the animal studies showed, oh, wait a minute, this masculinizes. So suddenly the human studies were like, wait, women who got DES are more masculine. It turns out that in the big controlled studies that have massive numbers of people and have good questionnaires and don't have biased samples, there are no effects on behavior at all. There are no effects on masculine or feminine behavior or sexual orientation. So that's all the specific evidence that I have time to present tonight, but you begin to get a taste of the problems in this work. There's a spectacular amount of conceptual diversity, change, and incoherence. Simple, familiar terms cover this variety so that sex, gender, and sexuality appear to be stable and natural in these studies, and the theory appears to provide a very good description of human development. All right, I'm gonna just say that if you've had training in neuroscience and behavior in particular, you might be surprised by the big mess that I'm talking about, because my findings strongly contradict the usual interpretation of studies in this field. But from another perspective, my findings are utterly predictable. What if we began instead with the data? What if we began with how women and men actually think and behave? If we began with evidence about variation in human cognition and personality, or the evidence about variation in human brain structures, would a theory of male or female brains emerge? I've been asking this question for a long time, and I'm certainly not the first to ask it. Catherine Vidal has asked it, for sure. So have other scientists like Janet Hyde, Anne Fausto Sterling, Anneliese Kaiser, some of you might know that. I could go on, and Ruth Bleier. I could go many others over the course of decades. But recently, we got a real boost in our ability to answer this question and to give you good pictures about what it means, thanks to analyses from the neuroscientist Daphne Joel and her colleagues at Tel Aviv University. Some of you might have seen her publications or have heard her speak. We'll go back to the question of what counts as masculine or feminine. Now, scientists doing this work, mostly psychologists, take a bunch of traits. They either start with stereotypes, they always start with stereotypes, and often they use those to populate studies or just have a gigantic list of behaviors and personality traits, and give people, usually college students, questionnaires and see which things are on average different between the men and the women. They select literally any aspect of behavior, personality, cognition, or eroticism that differs on average. And for these traits, any one of those traits, if each one of those lines is a trait, like let's say it's aggression, or it's some kind of spatial relations, or it's sexual orientation to women, or a preference for having sex within a relationship with emotional commitment or something. Men tend to fall on one side of those traits and women tend to fall on the other. Here you have somebody who's a little bit on the side of average for each of a bunch of different traits. Now, we'll call this person A. Here we have somebody who is much more having a tendency for the female typical version of these different traits. And here we have somebody who's really diverse and a lot over the place here. Now, average differences on all of these things are usually very small, and they almost always involve a lot of overlap between men and women. Almost all the traits that are studied in human brain organization research show more variation within the sexes than between them. But it's not just that women aren't uniformly feminine, or men can range from masculine to feminine, or that some people are androgynous, like this person, or to some extent the first person I showed you. Our folk wisdom suggests, let's see if I can go back to it. No, go back. Our folk wisdom suggests that most people will be like person B, and be generally feminine or generally masculine. And that then there will be some people who might be, more or less androgynous like this person, or really much more dramatically androgynous. But it turns out, and you see this in Janet Hyde's work, but you see it even more dramatically in Daphne Joel's work, that this person, person C, turns out to actually be the typical person. So let's take a look at, and what does that mean? That means that any one of these traits are very independent. Masculinity and femininity is not a package deal. There are average differences in certain brain structures, there are average differences in personality and so on. But to think of those things as masculine or feminine is actually only good to think about population level. It's not any good for thinking about individuals. You can't take the measure of aggression and know if somebody is going to be good at rotating an object in space, a spatial relation task. You can't take high libido and know anything about somebody's verbal ability, for example, or something about a particular structure. Here are a few slides from Daphne Joel's analysis, which she generously agreed that I could share. She used a large data set on human brains. This particular data set was 112 men and 169 women. And it's only 8, this is an analysis of actual brain structures. From this big data set, she chose the 8 structures that showed the most difference between males and females in the group, and then took the male form, female form, and then she looked at each individual brain to say, do you have the male form or the female form in this area? And this is actually what she found. Every row across is an individual person. And so you see, over here are the men, over here are the women. You see this incredible variation, what you could call mosaicism. What she found was that it was normal for people to have very mixed brains. Here, and she contrasts it with what you see, this comes from this art project, The Great Wall of Vagina. And over here, she created what she calls the Great Wall of Penises. But the difference here is quite pronounced. There's a lot of variety in each of these, but each one falls pretty clearly into a type. You can type them more or less in a way that is just simply not possible with the brain structures. Now, she repeated the same analysis on another, even bigger data set, and this time she chose 16 regions instead of 8. And she found exactly the same thing, the same kind of very mixed pattern. So then she did the same analysis for personality traits and characteristics, the gender mosaic. She, this time it's thousands, it's over 5,000, I think, or right around 5,000 females and males, young adults, 18 to 26. There were 28 variables, and again, she chose the 8 that had the largest differences, going from what's considered a moderate sex difference to some that were very large. So these were the most pronounced male and female characteristics. What did she find? Here it is. 97% had both feminine and masculine. 80% had at least 2 feminine and 2 masculine. 45% had at least 3 feminine and 3 masculine. So the idea of male personalities and female personalities, even for those things that are considered the absolute signal traits of masculinity and femininity, is the exception. It's not the norm. Okay. This is what it looks like visually for personality. So, here's the final takeaway. Daphne Joel's wonderful chart should remind you a little bit about that sexual orientation Venn diagram I showed you. Inconsistency is not noise in the data. It is the phenomenon. It is the typical pattern. Neither brains, nor personalities, nor hormones, nor ways of thinking are pink or blue. They're not male or female. The gender types are abstracts that don't describe real human beings very well at all. And that is perhaps the main reason to rethink brain organization theory. In closing, I want to be clear again that steroid hormones are without question important in early development. They have effects. and thousands of experiments in other animals support a general principle that androgens at critical points in development increase both masculine body features and behavior, most importantly leading to the development of male genitals and the sexual behaviors that allow males to reproduce, like mounting. Androgens are also crucial for genital development in humans, but those differences across various species are huge, and they're extremely important, and the farther away that studies get from genital development and the mechanics of sexual reproduction, the more variation there is. It turns out that sometimes it's actually estrogen and not testosterone or other androgens that are causing a masculine structure or behavior to develop. Hormones are complex, they aren't pink or blue, and environments are important. In the animal studies, we've known for decades that the changes that are created by these early hormone effects are not permanent. They can be reversed by fairly simple interventions, like the way you handle an animal or changing their cage mates for as little as an hour. That's not permanent. There are signs that some of the most careful and creative scientists working on sex and development in non-human animals, where they can do actual experiments, have begun to give up on classic brain organization theory. This theory is grossly out of step with current biological frameworks for development and neuroscientific evidence on brain plasticity. We need a new focus on development as dynamic, related to context and random events, and I propose that human studies, as animal research increasingly does, should attempt to understand processes rather than permanent states. So, okay, for time, I have to just stop some of these things I'm desperate to tell you, but we have to work harder to get past hormone folklore if we want useful science. This theory is hormone folklore, and it's time to drop it. Thank you so much for allowing me to share these ideas and for your patience with the problems.
Simplement pour vous dire que j'ai eu la chance de lire cet été le livre en français, qui est donc d'une écriture et d'une fluidité remarquable. Je tiens à le souligner parce que c'est un livre qui fait quand même 600 pages avec la bibliographie et les notes de bas de page. Le manuscrit, pour m'en parler, doit en faire un peu plus de 450 si je ne dis pas de bêtises. Et c'est certainement, on peut faire l'hypothèse qu'il y a une première écriture originale très fluide et une excellente traduction. Il faut quand même souligner ce travail exceptionnel qui a été fait. Ça, c'est la première chose. La deuxième chose, j'aurais une question qui ne s'adresse pas en fait à Rebecca, mais peut-être plutôt à Florence. Quand aurons-nous la chance, le privilège, le plaisir de pouvoir enfin toucher ce livre, avoir ce livre? Je pensais qu'on l'aurait aujourd'hui, mais c'est manifestement pas le cas. Voilà. Alors, moi, je trouve qu'il y avait plein de gens, en particulier les gens qui sont dans la salle, qui étaient beaucoup mieux placés que moi pour mener cette discussion, mais je comprends aussi que pour des raisons disciplinaires, on m'ait demandé de donner un point de vue parce que je suis psychologue. Et donc lire le livre de Rebecca quand on est psychologue, c'est faire l'expérience d'affects extrêmement contrastés qui vont de la stupeur. On est quand même souvent stupéfié par la puissance, la force de ce paradigme de l'organisation du cerveau, son caractère éminemment, comment dire, dominant, comme paradigme dans la psychologie nord-américaine. Donc ça, je peux peut-être en dire deux mots de cette stupeur qu'on peut avoir de découvrir tout ça. La colère, parce que c'est aussi des recherches qui écrasent d'autres possibilités de penser les questions de différence de genre dans le domaine de la psychologie, et puis à certains moments des affects carrément dépressifs, parce qu'on se dit que c'est quand même beaucoup d'argent qui sont dépensés pour faire ça et donc pour ne pas faire autre chose. Et dans la mesure où on voit arriver en France, les psychobiologistes sont en train d'armer une espèce de machine de guerre contre la psychologie française quand même pour s'infiltrer le plus possible, une certaine inquiétude. Alors, il faut quand même dire 2 mots pour souligner. Donc, vous l'avez entendu, la grande rigueur du livre, son exhaustivité, qui rend accessible donc des données scientifiques complexes sur 50 ans d'études. Et le travail qui a été réalisé est vraiment un travail énorme. Alors, Rebecca Jordan-Young cite dans une note de bas de page une étude de Jennifer Terry qui est intitulée « Une obsession américaine, science, médecine et homosexualité à l'époque moderne ». Et je trouve que ce titre résume bien l'impression qu'on peut avoir à la lecture de ce livre. C'est vrai qu'il y a une véritable obsession. Alors évidemment, elle ne parle que de ces scientifiques-là, donc du coup, ça donne à cette obsession une ampleur encore plus remarquable. Mais il y a vraiment les scientifiques paraissent obsédés par l'influence des hormones sur le comportement sexuel et l'orientation sexuelle à des années-lumière des préoccupations ordinaires des hommes et des femmes. Voilà. Bon. Donc on se pose vraiment la question à quoi servent ces recherches? Et il y a quand même beaucoup d'éléments dans le livre que Rebecca n'a pas forcément abordé, mais on voit comment ça vient nourrir, comment ces recherches apportent des contributions non négligeables à des points de vue qui sont des points de vue conservateurs sur les questions de genre, en les drapant dans un espèce de voile de modernité, d'évolution. Alors, on le voit très bien, je vais donner un petit exemple, parce qu'elle n'en a pas parlé, c'est très intéressant, à propos de ce que ça peut donner autour des controverses qui touchent à la question de la pénurie de femmes au poste de plus haut niveau. Alors, elle cite un responsable du MIT, et je voudrais quand même juste, qui s'appelle le professeur Roy Baumeister, et qui dit quand même quelque chose que je voulais faire entendre en ces lieux. Il dit: peut-être que les femmes peuvent parfaitement bien faire des maths et des sciences, mais elles n'aiment tout simplement pas ça. Après tout, la plupart des hommes n'aiment pas les maths non plus. Il y a probablement plus d'hommes que de femmes dans la petite minorité des gens qui aiment les maths. Et selon la même logique, je présume que la plupart des hommes pourraient eux aussi apprendre à parfaitement bien changer les couches et passer l'aspirateur sous le canapé. Et que si les hommes ne font pas ces choses-là, c'est parce qu'ils n'ont pas envie ou n'aiment pas le faire, et non pas parce qu'ils en sont constitutivement incapables, comme ils peuvent, à l'occasion, le prétendre par ailleurs. Donc vous voyez qu'à une époque où la diversité est célébrée, soutenir l'idée du sexe du cerveau n'équivaut donc plus à endosser l'idée d'une supériorité masculine. C'est beaucoup plus compliqué que ça. On a donc... alors que l'idée de préférence naturellement différente chez les hommes et les femmes était à une époque politiquement suspecte, on avance maintenant souvent qu'accepter ces différences innées favorisera une approche plus rationnelle de l'objectif d'égalité. Et vous voyez, ce n'est pas posé en termes de capacité, d'aptitude, etc., mais bien en termes d'intérêt ou de préférence. C'est là où je trouve qu'il y a des habits neufs qui sont offerts par cette théorie pour maintenir des points de vue extrêmement conservateurs. Tout changer, vous savez la fameuse formule de Lampedusa, tout changer pour que rien ne change. C'est tout à fait ça. Alors, stupeur de voir, alors moi j'enseigne quand même un petit peu la psychologie, donc on enseigne aussi des auteurs du 19e siècle, stupeur de voir que, comme à l'époque de Lombroso, on continue à pratiquer Rebecca en a parlé un tout petit peu. Hein, alors moi, par exemple, je suis gauchère, alors j'apprends qu'être gauchère, ça veut dire quelque chose peut-être par rapport à ma masculinité. Mais on apprend aussi qu'on peut comparer la taille des doigts avec... Mais moi, je pensais que, naïvement, hein, que ce genre de recherche appartenait au folklore. J'aime beaucoup l'expression folklore des hormones. Appartenait au folklore de ma discipline. Non, pas du tout. Hein. La craniométrie du 19e siècle n'a vraiment rien à envier aux recherches qui sont menées par ailleurs et qui coûtent, je vous rappelle, encore une fois, beaucoup d'argent et qui sont certainement publiées dans des revues qui sont des revues qui apportent des points dans les classements de Shanghai, etc. C'est là où les affects deviennent dépressifs. Donc je ne vais pas m'attarder plus longuement. Je vais dire simplement une dernière chose parce que Rebecca n'en a pas du tout parlé. Il y a une partie de son travail qui est vraiment passionnante, qui est consacrée à l'indifférence avec laquelle les chercheurs qui travaillent dans ce paradigme traitent les expériences vécues et les conditions de vie des enfants intersexués, en particulier de certaines filles qui sont au cœur de ces paradigmes comparatifs et qui ont un vécu très douloureux lié à un nombre important d'interventions chirurgicales, des traitements hormonaux lourds, etc., etc. Et Rebecca dit à juste titre que en travaillant pendant des décennies dans ce paradigme, ces chercheurs ne peuvent pas ignorer la souffrance vécue par ces personnes et que pourtant il n'y en a aucun écho dans leur recherche. Et donc il y a donc aussi en creux dans le livre de Rebecca, quelque chose qui, moi, me touche et m'intéresse beaucoup, qui est qu'est-ce que c'est qu'une science, éthiquement, hein, une science qui ne prête pas attention au sujet qu'elle étudie. C'est-à-dire une science où les chercheurs, à la limite, savent ou ne savent pas que leur théorie vaut plus, à leurs yeux, que les sujets qu'ils étudient. Et voilà, et donc je m'arrêterai là-dessus, parce que ça, je pense que c'est vraiment pour moi un des apports extrêmement importants de ce livre, de problématiser cette question et de l'instruire très concrètement à partir de cette série de recherches. Voilà, donc j'aurais bien d'autres choses à dire, mais je vais m'arrêter là et passer la parole à la salle. Donc je vais vous inviter maintenant à faire vos commentaires, poser vos questions. Merci à tous.
The question is, this is a student in biology, and she would like to know how was my book received by scientists who do this work, and also by biologists in general, and how did I negotiate that? So it's been a microphone again. The reception has been mixed, but surprisingly positive from scientists, I will tell you. There are some, well, I'll say, I was invited a few years ago to give the keynote presentation at the International Association of Sex Researchers when they were meeting in Lisbon, Portugal. And I got on the program not because everyone was thrilled that I would be there, but there's a particular young scientist who's a real feminist and is up and coming and got me invited as the keynote speaker. And it was quite something else. It was huge. This audience was full of people whose work I have critically analyzed. And I will tell you that if some of them had had tomatoes to throw at me, they would have been delighted to throw some tomatoes. It made some people really upset. But there were others who, from that talk forward, began to really engage with me. And it's been fantastic. And I've also had the opportunity to organize things with scientists who do work on brain organization theory and to visit their symposia. Mostly the people who have been receptive to me have been people who do experiments with animals. The people who actually do the human work have been the least receptive in general. Although a few, I will say that one researcher said to me after the presentation in Lisbon, "Oh, I enjoyed the way you cut everyone up by the knees." People have had a good sense of humor and have wanted to engage, but mostly they feel like, for example, Melissa Hines is a very important researcher in this field. Her complaint is she feels that I have not made a distinction between the really excellent work in this field and the other work. But to be clear, I was being comprehensive. This network you have to look at how it comes together. And I give much more attention in the book to studies that are influential, to the things that are really cited a lot. I do not, as she suggested at one point, pick lemons. I don't look for the weak, the poor studies. I really gave attention to the big stuff. So the question is, she has read the book and really wants to know, is brain organization theory really still the dominant model? And do I take into account the internal critics coming from within psychoneuroendocrinology? So I'll say it's a very interesting state of affairs, how to think of it, the dominance of the model. And I would argue that it is still very dominant, even though, especially, again, among animal researchers, there are people who have called for getting rid of this linear model, this sequential model, etc. So there was a very famous piece by Margaret McCarthy and Art Arnold, I think they published in 2011, and they talk about beyond this model. But you know, it's very interesting, even within that piece, they start out saying this isn't really the way it works, but there are many places in the piece where they go back to this simple heuristic about organization of the brain by sex. And it's been a dominant model for so long that it's going to take a really long time, and it's going to take very close, hard work by people doing the writing up their own research, by editors in journals. It's going to take a lot, because even in that one piece, they end up actually contradicting this complex model with some of their figures and in other parts of the text. It's quite important. But whenever you look for review articles, for example, you see that the theory is, again, enlivened. It seems like, to me, from a pedagogical perspective, what's going on is that people believe that, okay, we know it doesn't really exactly work like that. There are all these exceptions, it's not global, etc. But this is the way students have to learn it. We're going to start here because this is the simple way, and we start with simple, and we'll get complex later. But what happens is you drill that in as the model, and that shapes the thinking forever. You don't then move away from the basic model. It's the same thing that happened with the sort of master molecule idea of genetics, the idea that genes control everything. People have known for decades and decades that's not actually the way genetics works. We're maybe finally moving into an era where, you know, epigenetics, for example, as a catchword, it's not just as easy as we know it doesn't work that way. Now, meanwhile, that's within the science, and that's within the experimental science. Where we're talking about humans, because you cannot do experiments, this theory is still much, much stronger. The work that's done in humans, there are several reasons. It's relatively cheap to do. You can do it without a whole lot of, you can find a bunch of, undergraduates. It's better yet if you have access to an fMRI imaging machine, and you can come up with lots of variables. And it's relatively cheap, and it's something that seems like it really matters a lot to how we are in our daily lives. So you can also maybe get attention for it. It is appealing to do, and it gets a lot of press. When these studies come out, they get a lot of press, and there are lots of reasons that young scientists want their work to be covered. So again, the theory is, I don't think it's going anywhere as fast as it ought to. Mm-hmm. Similarly, to after the book was published, have I seen a difference in terms of the way that journals or that journal articles have had to be more specific with their definitions, their measures, statistical treatment, et cetera, et cetera. I will say that I'm currently working on a book about testosterone, and some of the things that I saw when I looked very closely at this massive body of work, it overlaps somewhat. But in other areas of testosterone research, sadly, the terrible statistical practice that I found to be very, very common in brain organization studies is not just there. It's in lots of other places. Now, testosterone is also, the home of hormone folklore. So there are reasons that poorly designed studies might not get such a close look in both of these fields. But overall, I haven't seen a big change. I will mention, for example, I think quite good example. Recently, there was a study by a very prominent geneticist, Belin, who's at UCLA, right? And there's a study where he did a mouse model of Klinefelter Syndrome. And the rationale here is the idea of looking for feminized behaviors. If you have a genetically altered mouse that has a mouse model of Klinefelter's, does that mouse have feminized behaviors? Well, this is a very classic example of a problem because men with Klinefelter syndrome do not have feminized behaviors. So here you begin with this assumption, and I read the article and I thought, am I forgetting the research on Klinefelters? So I ran back and I did a bunch of looking. Absolutely no. There's
tell us what
Klinefelter syndrome. Okay, yes. It's a chromosomal atypical pattern with XXY chromosomes. So it's an additional X chromosome. There are cognitive effects and there are behavioral effects and so on. And so in this particular article by Belin, they want to know, is sexual orientation feminized? But it turns out sexual orientation is not, in the literature that I've been able to find, associated with Klinefelter syndrome, except that in boys and men who've been studied, they tend to be later to develop and not show as much interest in girls at an early stage. But that's a very, very different construct. So you see what's happening. There's this slippage. The idea really fits very well from a folk perspective. Oh, you have an extra X chromosome. Sarah Richardson's work tells us that the X and the Y chromosome have gotten this notion of being the sex chromosomes. The idea that the X carries femaleness is another kind of fantasy. And the way studies get structured follows these folk ways of thinking instead of carefully matching up with what we actually know from empirical studies piece by piece by piece. My understanding of the question is this brain organization theory from the perspective of a historian is just the latest head of a monster that has had many heads, and you keep cutting off the head, a new head grows. And we know this is true. There have been many versions. You mentioned Lombroso, right? And actually, you'll love this. I think one of the scientists I interviewed, very, very well-known, important scientist, shocked me when he said during our interview, well, we're basically just modern-day phrenologists. So phrenology was that study, the science of reading the personality off the lumps on the head. And I thought, oh my goodness, you know that. You know that. But yeah, exactly. And what he meant by that was that the theory of localized function had gone out of style, and now localized function is back. But for him, being part of this line of phrenology was A-okay. It had been recuperated as part of the scientific trend instead of, quack, phony science. So history is very, very important to think about and understand why we're doing this. I agree that I haven't killed the monster. And the monster is going to take a lot of new shapes. But I think that I have been given really important new tools in my own understanding of how to think critically, how to read scientific work, how to read the newspaper, how to interact with people because of the critical science and technology studies and the critical gender studies that I've read. I know, although we've never met, that Londa Shivinger is right here. She's someone whose work influenced and informed my understanding of, for example, the way that important knowledge gets lost, and how important it is to pay attention to the ideas that seem to just slip away. How does that happen? To study it actively. We need these tools. It's not a fight that we win once and for all, but in order to be careful thinkers, we need as many examples and as many models for how to approach lazy thinking and habitual thinking as possible. And so that's what I hope that I'm doing. So I would first point out that historically, essentialism doesn't have just one valence politically. It's not just conservative, as you said. It's not just progressive. Similar to difference. Difference versus similar. Difference is not bad for politics and bad for equality any more than similarity is. People make arguments from all these positions. Many of the scientists doing this kind of work are, in fact, sort of naive liberals who believe that they're doing good work to show, to support diversity and show that the diversity of our personalities and our sexuality just comes from nature and you shouldn't do anything about it, it's fine. And there's a lot of naivete. There's so many stories I could go into with that, but I want to address the idea, first of all, that in the US, there is this argument that biology and an essential difference is the basis of rights. That's actually not correct. That is one reading of rights, and there's one legal thread of argument that puts it that way. But there's a very robust contrary thread that would base sexual rights on the whole history of, say, freedom of religion and freedom of association. There's a beautiful book by Janet Jacobson and Anne Pellegrini called Love the Sin. That's one of my favorite titles ever. But and there are people at, for example, the Center for Gender and Sexuality Law at Columbia Law School who are assembling the history, the story of precedent for taking sexual and gender law and putting it on a different basis instead of essentialism. And so I think that's important. We need to not just concede that that's the legal basis for rights. I think a very important lesson for politics is that for people who are working for justice and respect for all people, we must not make those approaches contingent on some scientific finding. Science changes. Science is not one thing. It doesn't have one voice. It changes and develops. What we see today might not feel true tomorrow. We don't want, it's actually something quite flimsy for hanging justice and respect for all people. We need a different kind of basis that comes from other ethical commitments that we must simply approach from the basis of what human beings are due. And for that reason, I think that we should work very, very hard to keep these questions about why we are, how we are, separate from what we deserve as human beings in terms of rights and privileges in the public sphere.